discussing iodine, how it works in the body. There's quite a bit of controversy once you actually dive into iodine and then how that actually functions in the body. So again, appreciate your time, appreciate your energy and your effort in being here. If you have any questions, we can follow up at the end. All right, so for those who want to know exactly what's going on in the order this is going to happen, we're going to talk about iodine and iodide, the history of iodine, the Iodine Project, which is a pretty interesting thing, controversy that surrounds both that and iodine itself, thyroid and iodine, how iodine functions in the body, the role of iodine, and then a Q&A. The big question is, well, do you have too much iodine? Do you have too little iodine? And who really determines this amount? It gets complicated. So let's dive in and take a look. At Tennant Products, this is a lot more than a job for us. It's our passion. We do go the extra mile to make sure that we have the best possible ingredients, therapeutic grade ingredients, and in the best possible quality, especially in these times currently. We're going to extra efforts to make sure that we can give you the best possible ingredients and not cut corners. We are family owned and operated, and we know that ingredients matter. We're going to talk about ingredients a little bit as well. And we've all overcome our health challenges, and that fight and passion that we have, we bring to each one of our products. All right, so let's dive in. So iodine, let's go over the facts about iodine. Well, iodine we know is a trace mineral. So trace minerals are required for many different biochemical systems in our bodies, but they're absorbed in small quantities. And traditionally, the FDA does not have a specific set of values for trace minerals. They're coming out with some, and they actually have some that they've created for iodine, but they're still controversial. The bottom line is that because it's a trace mineral, it's something that we actually need. Our bodies need it for many different biological systems, but it can't absorb it in large quantities. The other thing is that 30% of the iodine is stored in the thyroid gland. All right, so 30% of iodine is stored in the thyroid gland. It's interesting when we think about the thyroid. Thyroid and iodine are partners. They work in tandem, and the 3 and the 4 in T3 and T4, those hormones are actually the number of iodine molecules in each one of those. So that's how critical it actually is. So when we think about the thyroid gland, 30% of the body's iodine is actually stored in the thyroid gland, and it concentrates it there. Another interesting fact is that 90% of iodine is released. So iodine doesn't actually stay in a body. It's not like vitamin D that's fat soluble, or it sits in a cell and can sit in a fat cell and then you can pull it out over time. About 90% of that actually leaves. And so we have to maintain iodine replenishment. And then 70% of iodine is used throughout the body, but it's primarily in breast tissue and the ovaries and the prostate, salivary glands, the stomach lining, and the cerebral spinal fluid. Dr. Brownstein will tell us that iodine is found in each cell of the trillions of cells in the body, and without adequate iodine levels, life itself is not possible. It's pretty interesting when we think about how important iodine is across the board. It's absolutely integral for optimal health. And then a little fun fact here, if you have cold feet, there's actually a study that I found that cold feet are often associated with a thyroid issue. And if you have appropriate levels of iodine, it has been shown to help resolve that. So if you're struggling with cold feet, or your partner struggling with cold feet, that might be a good study to present to them. All right, so iodine and controversy. Well, we know a couple more facts, right? Iodine's a trace mineral the body needs. Iodine's an effective disinfectant and antimicrobial treatment. It's been used since the 1840s consistently in medical practice, and iodine helps support healthy thyroid levels. And it was, we have proof of this because we actually had an issue with a goiter belt in the Midwest in the 1800s, and the FDA finally stepped in and said, hey, if we add a little bit of iodized salt to the table salt that everybody eats, and it's just enough to actually just enough to support the thyroid, then maybe we can resolve this. And then 20 or 30 years later, they actually looked at the data and they actually saw that it actually helped resolve that. So that's how we ended up with iodized table salt. People are moving away from iodized table salt these days, and so we'll get into that here in a little bit. But there are some controversial questions when we think about iodine. And one of those is, how much does the body need? And you think that'd be a simple answer, but there are a couple of trains of thought with that. The next is, how does one measure adequate iodine levels? Is it the amount that the body actually biochemically needs? Is it different for each person? Is it different for different life stages of a person? And there are so many questions with this that it becomes controversial. And here are the two thoughts. So on one side of the screen, we have our standard medical practice. And standard medical practice in the United States shows that elevated levels of iodine can be dangerous and hazardous to one's health. If we look at the flip side of that, on the controversial side, there's a group called the Iodine Project, and they have come up with many different theories that alternative medicine and functional medicine actually come up with today. And that is that high iodine levels are protected through the body through the Wolff-Chaikoff effect. It's basically a safe mechanism that the body has, and that iodine is safe and non-toxic even at high levels. So kind of counterbalances themselves there. And then we have iodine levels that are measured by the average level of blood serum and taken over a group of individuals. This is how the FDA does that. They actually take an average of the individuals. They take the average iodine level from that, and then they get the average iodine level for the FDA that the FDA uses. The other group will actually posit that iodine levels can be measured by blood serum or urinalysis, and it's based on an individual's specific need and biomarkers. So they will look specifically at the clinical signs, what's actually happening in their bodies, what do the blood tests actually look like, and they will say that it's ineffective because the majority of America has grossly depleted iodine levels, and we need to actually increase that. And if you're taking an average or a mean of people that are ridiculously low in iodine levels, then it's going to be low anyway, and you're just getting an average of inadequate iodine levels. So a little bit of a conflict there. And that the majority of the population maintains adequate iodine levels is what the statement before actually presumes. And the alternative statement is that the majority of the population is severely iodine deficient. Kind of interesting and controversial as we dive into this. Now, there's this group called the Iodine Project. There are 4 doctors that got together, and their thought was, let's treat the symptoms and not mask them. The thought was, hey, look, iodine has been used for years. Specifically, Lugol solution has been used for almost 200 years without very many adverse effects. And even a couple of the physicians that helped start the Iodine Project said that if they were only given one thing to help treat, that they would choose iodine over anything else. And the basic presumption with this is that iodine has been used for the last couple hundred years as viable medical treatment. Specifically, the Lugol solution, without significant side effects, can it still be effective today? And they argue that it certainly can. Now, is this controversial or is it visionary? Well, it depends on which side of the fence that you're on. And actually, there are clinical studies that help support both sides of the argument. And we'll dive into that here. So started in 1998, 4 physicians decided to publish concepts in a specific magazine. These ideas went against the majority of the literature that have been out from iodine for the last 100 years. The concepts are controversial, but they shape much of the current iodine research today. And some of those concepts are that iodine deficiency is common, people with thyroid disease need more iodine, and that halides are toxic. And then everything is consistently referencing Lugol's formula. And we actually have Dr. Tennant's Lugol's iodine formula. And so we go, okay, well, if you have 2 people's names in a label, then who is Lugol? Well, Jean-Guillaume Auguste Lugol developed Lugol's iodine solution in 1829, initially as a cure for tuberculosis, and then it stemmed off from there. Lugol's iodine solution continues to be used in the medical field and is used today as a disinfectant and various other medical applications. When we take a look at what else is happening, it's still being used, and it's being used in natural medicine as well as Western medicine. It's just limited in the use that it has been since the 1950s or 60s. So when we think about the Iodine Project, these 4 guys that came together that started to talk about this, they have 7 basic claims. And one is that iodine deficiency is rampant in America. and that the majority of the population, even the FDA standards of the average mean, are incredibly low. The RDA of iodine at 150 micrograms per day is grossly inadequate. That's the FDA standard based on the average American. Iodine is essentially non-toxic, and then halides, bromine, specifically bromine, fluoride, chlorine, all have an effect on iodine that decreases the effectiveness of it. Iodine cannot slow the thyroid, which is the Wolff-Chaikoff effect. It's interesting because when iodine is given in a large bolus, there's a phenomenon, or all at once, there's a phenomenon called the Wolff-Chaikoff effect, which is kind of the body's built-in safety mechanism, where it actually inhibits thyroid hormone synthesis and basically dumps that off. So it's one way to actually help keep things safeguarded. And then how is iodine elevated? Well, their urine tests. Urine tests have not thought to be specific before. These guys have come out and said, well, actually, the body will dismiss whatever isn't needed, and so they'll give a bolus of iodine, and then if your body actually absorbs that iodine, it must have needed it, and that if there's a high level of urine with that, then your body is actually fine and and has all of the iodine that it needs. It's kind of an interesting test. And then the seventh thing is that iodine can cause TSH, or thyroid stimulating hormones, to elevate. And this is a good result, which is against what the traditional medicine would say. Excuse me. Now, a couple of things that stemmed from this is that the iodine has been used, and then it's consecutively been banned as it goes along. So the 1950s and 60s, iodine was frequently used as a hand sanitizer. It was used for about 60 years as an effective hand sanitizer. And then folks started to notice higher rates of people who were using this hand sanitizer more often, nurses and doctors and folks who were in the hospitals who were using it consistently, and that they had higher rates of thyroid disease and unsafe blood levels of iodine, according to the FDA. And so they banned the use of this hand sanitizer. And then in the 1970s, a similar train of thought that iodine is unsafe came by, which kind of further exacerbates the controversy by saying that they replaced iodine, which was used in baking goods, with bromine, as iodine is thought to have negative health effects on the body and increase blood iodine levels. And so really the best way, when you think about these two things, you really have to say, okay, well, great a minute. There are two trains of thought here, but what are the symptoms, right? Are you experiencing an iodine deficiency? Are the people that you're working with experiencing an iodine deficiency? What does that actually look like? And if so, then what are some of the symptoms of that, so that we can actually start to look for it? And the symptoms of iodine deficiency would be brain fog. So especially in the morning. So if you wake up, you feel unrested, even though you've got adequate sleep, you're still unrested and having a difficult time thinking. Obesity, so slower metabolism. Obviously, there are many different things for this, but when we're looking at the totality of the circumstances, these are all things that are required to have adequate iodine levels. Psychiatric disorders, mental retardation. So you actually have to have adequate iodine levels while pregnant in order to be able to maintain proper brain function. It also works to help maintain brain function as adults. And we've actually seen treatments for ADHD increase the levels of iodine that have actually helped. In cancer, specifically breast, stomach, ovarian, and prostate cancer, fibrocystic breast, cysts in ovaries, testicles, or prostate, goiter, which is an inflamed thyroid, polycystic ovarian system, or saliva deficiency. So if you don't have enough saliva, you're probably iodine deficient. One of the main places that iodine is also stored is in saliva, and then thyroid nodules. Now, if we think about the amount of iodine that the body actually needs to consume, just to put things in perspective, for a daily level, and we were to go off of, let's say, the Iodine Project levels instead of the FDA, you would need to consume 6 eggs a day, or 2 large eggplants. So think of the largest eggplant you can think of. 2 of those a day, 11 cups of strawberries, or 1/8 of a cup of sea kelp. Now, the benefit of sea kelp is that it actually contains selenium, and you actually need selenium to be able to break down iodine. So we'll get into those cofactors. But the Iodine Project will argue that Japan's diet contains about 100 times more iodine than the recommended US dosage at 150 micrograms. And that if you look at the studies, Japan has fewer issues with Alzheimer's and ADHD and breast cancer and prostate cancer, which are typically associated with a thyroid condition or not enough iodine. Okay, so then let's dive in and talk about this a little bit. How does iodine actually work? Well, if we look at the periodic table of elements and you look at the teal column here, the teal column is the halogen group, or otherwise known as halides. And the thought here is that the fluoride, the chlorine, and the bromine, which are just above iodine in that column, actually all compete with iodine for iodine receptors in the cell. So when iodine comes into the cell has specific spots for it. And if you think of a cog in a wheel, you can have other things that can interfere with that. And bromine, chloride, and iodine can all interfere and actually take over that same receptor, which would decrease your ability for the body to actually be able to absorb that, right? And so when we're taking iodine, or if we want to increase our iodine levels, we want to make sure that we're not actually taking bromide, chloride, or fluoride. And interestingly enough, as we talked about, instead of having iodine in our baking products, we actually have bromine. So we have bromine or bromide in quite a few baking products. And so if you take a look at what you're actually eating, you may actually be consuming bromine and not even know about it. Same thing with your tap water. If you look at our label, we'll say do not take with chlorinated water, or take with purified non-chlorinated water. And the reason for this is that tap water typically contains chlorine and fluoride and several other things that can interfere directly with iodine. Now, iodine can kill quite a few things, but when we look at the periodic table of elements, we know that fluoride, chlorine, and bromine are all stronger and can interact with iodine. And so we want to make that point clear. So if you ever wonder why we actually have that written on the bottle, there's the answer. All right, and then we know that iodine is good with wound care, right? It was used initially, it was used to help treat tuberculosis, it was used in surgery systems, and if you've ever had, or surgery centers, and if you've ever had an injury or gone in for a surgery or getting a blood draw, they'll ask you if you're allergic to iodine. The reason for this is that it's a fantastic antiseptic and has been used back to the 1800s, but specifically in the 1940s is when it really kind of took off. The iodine is an effective topical antimicrobial and disinfectant. It's fantastic with viruses. I mean, you name it, right? Viruses, fungus, bacteria, and protozoa. And that's one of the reasons why it's still used today. Now, we do state, please don't take this with probiotics or Dr. Tennant's fungal detox, because it can decrease the effectiveness, right? If you're taking something that kills something else, then we don't want to take that at the same time. Interestingly enough, it's still used in surgery centers today, even though it's been pulled out as a hand sanitizer, and there have been several other restrictions put on it. All right, so what's one of the other things that iodine can do for us, aside from supporting the thyroid? Well, we know that we need it for iodine and digestion. Iodine is needed for digestion. So stomach acid or gastric acid is critical for optimal health and digestion. We know that there are several things that are needed to help create stomach acid: iodine, zinc, B1, and salt, actually, but we usually have salt present. And if we have enough stomach acid, then that can actually trigger, when the stomach acid actually hits the small intestine, it can actually trigger that duct to close, and then that sends off like nine biological other functions that help close off other valves and help stop with reflux. And so increasing the amount of stomach acid in your body can actually decrease the amount of heartburn or acid reflux. We know that iodine's critical and for making stomach acid, and stomach acid is critical for the digestive process. And without enough stomach acid, you're not able to absorb as many of the nutrients from our food. And so one of the signs of low stomach acid is undigested food or constipation. A lack of nutrients in vitamin or mineral deficiency. Stomach acid is kind of the first line of defense and responsible for killing harmful bacteria and neutralizing those enzymes. And low stomach acid can increase the susceptibility for disease and health complications. It can also lead to food sensitivities. If you're having significant food sensitivities, and I've experienced this in my own life, my daughter was experiencing that, and Dr. Tennant said, hey, I bet since she's breastfeeding, if you elevate your wife's iodine levels, then I bet her sensitivities will go away. And we were thinking it was crazy allergy. We saw 6 different allergists. I thought, well, why not? Let's give it a shot. Talked to 5 other doctors. They said, well, theoretically, that could make sense. And as we know it, we tested her 9 months later when we got into the program, and she's living a normal life now. So check with your practitioner before actually getting into something like that. But stomach acid can be absolutely crucial for food sensitivities. All right. You can say, well, Scott, I know that we have iodized table salt. Can I just eat table salt and get everything that I need? Well, the key here is that every tissue in the body requires iodine. We know that Dr. Brownstein said that every cell requires iodine as well. If we look at table salt specifically, there are 77 micrograms of iodine per gram in table salt. An individual's average intake of salt intake is 5 grams per day, which would be 385 micrograms per day. Urine tests actually show that this is lower because we know that the bioavailability of iodine is incredibly low, about 10%. Med schools are teaching that the existing iodine in salt is adequate. However, sea salt, which most people use, contains very little iodine, and the current recommended daily allowance for adults is 150 to 220 micrograms per day. Kind of interesting. Now, if we look at what the recommended daily amount from the FDA is, we have an adult male, which is 150 micrograms a day, adult female, which is 150 micrograms a day. If you're pregnant, we need to increase that level just a little bit. So that's recommended at 250 micrograms per day, or lactating, it's almost twice what it is of an normal adult female. Now, one thing to note here is that this statement was based on, and this information was based on preventing goiter, not for preventing overall biochemical iodine health. And that's what the Iodine Project argues. And the FDA says, well, we have enough in there. We obviously have enough in our diet. We're not having a goiter problem. The reality is that iodine does other things besides the thyroid. So we'll leave that discussion up to you. But the standard dosing for most healthcare practitioners is the standard Lugol's formula, 1 serving of Lugol's, which is now 12.5 milligrams daily as the current standard for adult supplementation. Now, it's important to work with a healthcare practitioner in every instance with this, and you'll hear me say this throughout this presentation. Iodine does have some contraindications, especially if you have an autoimmune thyroid condition. And so we want to make sure that we're adequately testing those iodine levels consistently. Okay, let's dive in. So we have thyroid, right? I've talked a lot about the salt. I've talked a lot about the thyroid and goiter, or the big lump in the neck, or an inflamed thyroid. So you say, well, how much do we actually need, Scott? Well, the thyroid alone needs 5 to 7 milligrams per day of iodine. And the thyroid is first in line of all the organs to get that. So if the thyroid doesn't get everything that it needs, it will take it from another place, which means if there isn't enough, then it's going to leave the other organs short. So 5 to 7 milligrams is equal to 5,000 to 7,000 micrograms, right? And if we go back and think about, that's significantly different from what the current RDA is. You can see where the controversy lies, right? So the thyroid gland needs more than 31 times the recommended amount of 220 micrograms per day for a pregnant woman. Now, breast tissue and reproductive tissues also require small amounts, as we saw earlier in the slides, and the body requires 2 different types of iodine. We need iodine and potassium iodide, or iodine and iodide. And thyroid prefers iodide, and breast and prostate tissues prefer iodine. And when we dive in, we take a look at iodine and the thyroid a little bit closer. Everybody talks about the T3 and T4 or your TSH levels. So when you get your standard blood panel and you look at this and you go, okay, well, yeah, well, I don't know. Do I need iodine? I don't know. Doctor runs a normal panel and says, okay, well, yeah, it looks like your T4 is normal. Your TSH is good, so no problem. Well, the thyroid is a huge part of this. And some of the things that the thyroid does in the body are increase cardiac output, support healthy ventilation rate. It supports your basal metabolic rate. It controls the fight or flight response. It thickens endometrium in females, and it increases the catabolism of carbohydrates and proteins. So if you're having issues with managing your metabolic rate or your cardiac output or your ventilation rate, right? We're just thinking about some of those things that are going in there. T3 is the active form of iodine, and T3 has to be converted in the body. It goes through a series of processes in this, and some of it's converted in the liver. Some is converted in the liver, some is converted in the kidneys. But it's a systemic process. And so it's not just all about the thyroid, it's actually all throughout the body. T4 or thyroxine is responsible for your metabolism, body temperature, and mood. And what we actually need is T3 and T4. And so if things don't work as effectively as they should, then we may not actually get T3, the active form of that. So how would we actually look at this? Well, if we have some potential causes for iodine deficiency. And so hypothyroidism or hypothyroid is too little thyroid produced. And so we've talked a lot about the nutritional deficiency in the soils. As it stands, unless you live within 100 miles of the coast or are eating a relatively heavy maritime diet, you're probably not going to have the iodine levels that you need in the diet to maintain adequate iodine levels. If you have issues converting iodine, because it's a systemic thing, it's not just the liver or not just the thyroid. If you have issues with your liver, with your gallbladder, with the thyroid, you can have issues with an iodine deficiency. If you don't have enough selenium, we talked about cofactors quite a bit, and selenium is actually required to convert T4 to T3. So if we don't have selenium, then that won't work. If you eat too many cruciferous vegetables, I love this one, because the way that this breaks down is that you have to eat like 4 heads of broccoli a day in order for the cruciferous vegetables to actually be able to absorb the iodine and then move forward. If you have a low salt diet, which can lead into many things, but particularly the iodized salt. When you think about endocrine disruptors, so pesticides or halides, these actually compete with the same receptors where iodine fits in. And so if that space is blocked, then iodine can't actually get in, and it affects the absorption of iodine. Stress, so cortisol eats away at vital minerals. It eats away at iodine, it eats away at magnesium, it eats away at many, many different minerals in our system and can be toxic at high levels. High levels of estrogen, which is interesting, right? When we think about the specific types of fibroids that come along with this, or the things that are associated with that, there are studies that actually show that decrease of common fibroids or issues with elevated iodine levels. And so high levels of estrogen can block the iodine absorption in the thyroid. So if pregnant, on hormone therapy, birth control, if you're eating hormone-filled food, or even if you have too much soy, especially if it's not fermented, can compete with the receptors on the iodine molecule to actually let that get in. If you have liver damage, because we need our livers to function, or if you don't have a gallbladder or you don't have enough bile, iodine can't convert into the active form. The result of this was that you would have normal T4 but no active T3, which would mean you're iodine deficient. Okay, so we know that 30% of iodine is located in the thyroid gland. T3 and T4 are thyroid hormones and 4 and the 3, or for the T4 and the T3, represent the number of iodine molecules present, right? Without adequate iodine levels, the thyroid gland is unable to produce adequate thyroid hormone. And not just the thyroid hormone needs iodine, there are other hormones that actually need iodine as well. But iodine deficiency can result in poorly functioning thyroid gland, goiter, or increased autoimmune problems. So the way that this works in our bodies is that the pituitary gland actually secretes thyroid stimulating hormone that goes to the thyroid gland, and then that actually increases T4 and T3. And so if you're low, it'll actually send out more TSH, and if you're high, it'll send out less TSH. And so I just wanted to put this into perspective on how that functions. So iodine is critical for this entire process. The thyroid is essential for normal brain function as well, especially if newborns, and if we look at that specifically, higher levels of iodine are required for normal brain development. And I mean, there was one study that actually talked specifically about fetal brain development, and that research has shown that almost 50% increase in prenatal mortality due to iodine deficiency. So I guess the question is, well, then why is the thyroid hormone so important? Well, every single cell, muscle, and organ in the body depends on adequate thyroid hormone levels for optimal functioning. The reason for this is that every cell needs iodine, and if the thyroid doesn't have it, it will take it from other places. And the thyroid hormone acts as the body's major metabolic regulator. So if you don't have enough of that thyroid hormone, and autoimmune presents itself, then you can end up with a potential autoimmune condition. And we get a lot of questions about iodine and Hashimoto's disease. And the common treatment is that the patient will see a doctor, and the doctor prescribes some thyroid prescription, right? Synthroid or something along those lines. And it supports the thyroid, but it doesn't actually fix the problem or give you energy. Which is what the Iodine Project was actually positing, that you need to fix the root cause instead of just the symptom. And it doesn't fix the fatigue, the brain fog, or the root cause of the problem. And the problem is actually not solved. There is a recent study that shows that 90% of all hypothyroid issues are related to Hashimoto's disease. Which is interesting when we think about this. So if you have low thyroid or hypothyroid, it could be, it could be 10% of the people that have issues with a high estrogen level, or too much soy, or something along the lines with the liver. But we're starting to see such an influx of autoimmune related conditions. And Hashimoto's is first and foremost an autoimmune condition. And it's specifically an autoimmune condition where the thyroid has antibodies that attack itself. And so when the body starts to attack itself, it's never fun. But one of the best ways to be able to produce that is to decrease the amount of inflammation overall. And when we decrease the amount of inflammation, things can be much, much better. And when you have an immune dysfunction that presents itself as a thyroid problem, but also affects the thyroid significantly, if you don't understand autoimmune disorders, it can be an even larger issue. And one of the things that we also talk about is that gluten can be a large trigger for Hashimoto's, as gluten can actually feed the antibodies for Hashimoto's. So if you're looking at Hashimoto's and iodine specifically, folks will say, well, hey, how does Lugol's iodine formula actually treat Hashimoto's? And the answer is not so simple, but it's twofold. And one is you have to treat the autoimmune disease as an autoimmune disease, and then you have to regulate and balance the thyroid levels. And so it's consistent management with the practitioner to help balance that out. And so when we look at triggers for autoimmune diseases, we have infections, hormones, right? So we need to make sure that hormones, which help trigger iodine, helps trigger and balance those. are at adequate levels. We need to decrease the amount of stress because we know that that can actually affect the amount of mineral content and those elemental minerals that we have in our bodies. Drugs and heavy metals and food antigens. There's a huge link between gut health and Hashimoto's. As we know, 70% of the immune system is in our digestive tract, and when we get imbalances or that dysbiosis, we have inflammation or other disorders, and it increases the likelihood of additional autoimmune diseases. And if we have an issue with the thyroid, then it can actually increase the likelihood of Hashimoto's as well. This imbalance actually creates, instead of having a smooth intestinal wall, it actually creates kind of like Velcro, so that toxins and undigested food and things of the sort can actually, those waste products can actually seep through, which can eventually lead to a leaky gut and an autoimmune condition. So if we think about what we've actually talked about with the microbiome and how that functions, and when we get into the bacteria creating the enzymes so that they can break things down so we don't have undigested food, so that we don't end up with leaky gut, those are some of the triggers. And so having a healthy diet and maintaining a lifestyle that can decrease the amount of inflammation is absolutely huge. So can you fix iodine, or can you fix Hashimoto's with iodine? No, you can't. It's an autoimmune thing. Iodine can certainly help with that, and you certainly need to work with your practitioner on that to make sure that you have adequate levels. So when we think about iodine, we know that iodine is found in each of the trillions of cells of the body, and without adequate iodine levels, life itself is not possible. David Brownstein, who was actually one of the members of the Iodine Project and did a bunch of work for that. He's written several books on iodine itself, talk specifically about how that works. And we know that iodine has so many different systems in the body, like so many different functions in the body, and works with so many different systems, and that we need to maintain adequate levels. It's the first line of defense against infections, both topically and within the body. It helps transport secretions from inside to outside the cell, and it's critical to regulate the thyroid hormone. It's great for energy production, strengthening the immune system, helping with cellular energy or voltage. We know that it's required for stomach acid, and then it promotes the balance of all the body's hormones, not just the thyroid. But we can't take iodine by itself because we need additional cofactors for it to be able to absorb. And Dr. Tennant will say iodine needs cofactors like zinc and selenium to work correctly. You can't just substitute iodine by itself and get the results that you need. So why are we using Lugol's formula? Well, Lugol's formula contains both iodine and iodide, which is what the body needs to function optimally. And Lugol's formula is a pure solution of both of those. It's iodine, potassium iodide, and combined with that with purified or distilled water. The thyroid uses iodine or iodized salt, and breast tissue and prostate tissue use iodine. It also contains the cofactors, right? So the zinc, the selenium, we know that selenium needs to be present to convert T4 to T3, vitamin C, thiamine, and fulvic acid. So we have the things present not only for iodine to be able to metabolize, but also and convert, but also to be able to create stomach acid. So this is really kind of a unique formula in that manner, kind of a one-stop shop in that. So if we think about iodine in itself, you can see how integral it is to optimal health, but you can also see how there's some controversy with this. So then the question is, well, how can you tell? Well, you need to look at things clinically. You need to look at what's actually happening in your body, and obviously work with practitioner to make sure that results are optimal. And if we think about what we've actually discussed, we know that iodine has been used for health and wellness since the 1800s. We know that iodine is an effective disinfectant and antimicrobial. Lugol's iodine solution has been most effective to provide both iodine and potassium iodide. And the thyroid requires iodine to make hormones and balance the rest of the body's hormones. Additional cofactors are required to convert and metabolize iodine, and converting iodine is a systems approach, right? So it's not just the thyroid, it's not just selenium, it's actually a systems approach with the liver, the gallbladder, the kidneys, and the thyroid. the Iodine Project, which seems controversial, does present alternative solutions to iodine and also supports them with clinical studies. Halides, estrogen, pesticides can all interfere with iodine absorption. Iodine needs to be replaced often because it's not stored well in the body. And Hashimoto's is an autoimmune condition, which should be treated as an autoimmune disorder with a practitioner's help while monitoring the thyroid. Iodine has many, many functions, including stirring up controversy. And with that, I thank you so much for your time. I hope this has been beneficial. Thank you so much for being interested in Tennant Products. We do believe that it is your life, it is your body, and ingredients do matter, and that when it does have what it needs, it does remember how to heal itself. Thank you so much, and